This is John Beck, super chemist. We're here to make some sodium hypoiodite, which is basically just bleach, but instead of chlorine, we're using iodine. So it's iodine bleach. This is a failure, so it did not work. Before I go over this stuff, I want you to see the correct equation, because I screwed it up and I have 4, 2, 2, 2. Should be 2, 1, 1, 1. Everything's a 1 except for this. It's a 2. I don't know why I screwed up the stoichiometry like that. I should have known by the disproportionation. You know what I mean? That you have 2 of them. One goes up, one goes down. So obviously, you know what I mean? This should have been a 2, not a 4. Duh. Anyways, just to let you know. I'm going to go over what we're doing about the sodium hypoiodite. But first I'm going to go over the chlorine analog of this whole deal here. Because a lot of people understand the chlorine part of it, but it's the same exact thing. I want you to think about how you make bleach, right? Sodium hypochlorite, right? You take some chlorine, bubble it into some sodium hydroxide, right? And you'll get this. When you buy bleach at the store, it actually has this much sodium chloride in it, because that's how they made it, right? Now, how do you make the chlorate? Okay. What do? You take that bleach and you boil it, and it disproportionates into sodium chloride and sodium chlorate, right? And this is the formula for it. Kind of, it's the iodine formula of it. But now I want you to think about what we're doing. We did the same exact thing on making bleach. The only thing is we're using iodine. Put I2 into sodium hydroxide. We didn't do any stoichiometry stuff because I'm just making a small amount. You want it to be dilute though. You don't want this to be, you know, thrown in a ton of. I probably only put about 5 grams in or something, and a couple grams here. And this, I think the molar mass of iodine is like 250 grams or something like that. So a gram or 2, say there's probably 2, 3 grams in there. That's nothing. That's like, you know, that's nothing. It's 100th of so anyways, you put it in there, and again, you make the same thing. Sodium hypoiodite instead of sodium hypochlorite, and sodium iodine instead of sodium chloride. Thing is iodine's a bigger molecule than, a bigger atom than chlorine, right? So you don't have to boil it for it to disproportionate, right? Remember how I said you take the bleach, you would boil it, and it would disproportionate. You would have a sodium chloride, right, that lost the oxygen, so it got reduced, and then you'd have a sodium chlorate that ends up with 3 O's instead of 1. See how this only has 1? It ends up with 3, so it gets oxidized, right? 1 gets oxidized, 1 gets reduced. Disproportionation, right? But here, it's easier to disproportionate. This is going to happen naturally. You don't even have to boil it. If you wanted to just make the iodate, you would just take the iodine, put it into hot sodium hydroxide, and it would just come out already disproportionated, right? So you don't really have to boil it per se. So this is what we did. This is what we have. Like I said, this naturally disproportionates. So what we made, as time progresses, that sodium hypoiodite will disproportionate to iodide and iodate, okay, given time. I want you to think, like in the thing of bleach, right, you don't just have, you have more ions and stuff in there that you would think. Here, look down here at this blue box, right? In bleach, you're going to have some acid, right? Just a little bit, because it's a basic solution, but you still have a little bit going in and out of solution, in and out. These things are just, everything is you know, it's an equilibrium. You know, everything's jumping back and forth just so everything's equalized, you know, overall. So you got so because of this is going to, if you have some of these, that means you have some protons and some OCl negative anions, right? Some of it's going to disproportionate, or some of it's going to disproportionate. Some of it's going to come apart. I can't even think. But you know what I'm saying? Some of it's going to, protons are going to jump off, and you're going to be left with that. You also have hydrochloric acid in there, right? So you have protons from that and chloride ions from it. You also have sodium chloride, so you have sodium ions and again chloride ions. You'll have chlorine, actual Cl2. That's why when you look at bleach, you know, you wash your clothes with or whatever, or clean with, you'll notice it's green. That's from the chlorine that's just is in there, you know, not a lot, but, and then it can come apart and give you chloride ions. So you have all of this inside bleach. You know, doing different stuff, going back and forth, you know what I mean? And I'm sure you have a little bit of this too happening, you know, even at room temperature, but really slow, you know. So anyways, that's pretty much it on the, you know, the equation in that. I just want it so that I can test for methyl ethyl ketones or alcohols that can be oxidized into methyl ketones. And that's it. That's all I want it for, so I don't really care that much about it being exact or this or that. I wanted to go over the science about it, and that's pretty much it. I didn't put the iodine directly into water or into sodium hydroxide water. Kind of just used the cleanup from my last video. My last video, I was cleaning up my iodine, and I put water through the iodine to clean it, and that water went into a 2000 round bottom flask. You'll see it here soon in the first clip, where it's red because some of the iodine is in the water, and also some just went through the filter. You know what I mean? Then I will show you a big pot where I put the frit funnel that I used to filter the iodine. I put it into that solution. Now that was not water. That was, well, it was water, but it was also sodium hydroxide. I put about maybe 10 grams in there or something like that. And then I put the frit funnel into that sodium hydroxide water so that it would absorb and react with the iodine, clean off the frit funnel. That is the first clip that I will show, and that's where I get my stuff from. Still got that iodine water there. And here's where I was cleaning that. Remember the funnel? Now that water has sodium hydroxide in it. So basically that's making bleach. Not sodium hypochlorite, but sodium, which is just basically iodine bleach. So we're finally going to make the sodium hypoiodite. You can see, remember that I had the little tiny filter thingy. Look at it. It's nice and clean. There's no iodine on it anymore because I put it in this sodium hydroxide solution here. Now what's in here? This is the water that I filtered through the iodine, you know, to clean it or whatever. So there's iodine in there and it's water. What I want to do, since this does have some iodine in it, I'm going to Try and put it right in there. So I'm adding sodium hydroxide to this iodine water solution so I can make the, just like when you add chlorine to sodium hydroxide, you make sodium hypochlorite. Here, I'm doing the same thing, except I'm adding it in reverse. I got your iodine there. It's mixing with the sodium hydroxide solution, and you're making your sodium hypoiodite. So I'm just going to pour this in. This has no lip on here, so I'm going to do this off the camera so I have room or whatever. And basically that's it. I'm just going to let that drip in, and there's your salt. I'm not going to try to purify it or extract it. Keep in mind, you're also making sodium chloride doing this. And you're making water. Well, so this is about a 2-liter flask. You see how much I got. You can see, just like on where it looks green when you make chlorine bleach, this looks kind of like brown, yellow, red, purplish type of color because of the iodine. You can see at the bottom here. I don't know if you can see that. See how there's some stuff down there, some solids. That's iodate, some iodine. Like I said, there's a lot of stuff that's in, a lot of ions, a lot of other stuff floating around in here. But anyways, there you go. I can toss that in the bottle. I'm just going to leave the solids in there. But I have a pH I did of 12. There's my thing. You can see it's purplish. Anyways, I checked it on the chart. It's a 12 or about. So there you have it. So there we go. We got our sodium hypoiodite solution, which is basically iodine bleach. So anyways, I've been trying to do the haloform reaction with this and make iodo instead of chloroform, iodoform. It's not working good. Either it comes out clear like that, or it just won't ever clear up like that. It doesn't matter what combination I use. Like start with the stuff that has a lot of crap in the bottom, like iodine and stuff, or I start with the stuff where I took all the iodine solids out. If I add more sodium hydroxide after, a little bit both, it doesn't matter what I do. I cannot get it to work. So I'm going to call this a failure. Have a great day, and remember, science is great. You can see I got some of it with the solids in the bottom. See that? Hoping some of that's the iodine. So I'm just going to pour a little bit of acetone in there. And I might as well put it all in there, screw it. And what I want is it to go clear. Get all that brown crap out of it, all that purple sugar there. I have some 2 molar sodium hydroxide. I'm just going to put in a little bit at a time. Keep stirring it till it goes colorless.